Good morning and happy Friday. So, today we're going to be talking a little bit about immunity, your body defenses. So, you had a packet last night about this, so you have a little bit of an intro to it, and that gets into a little bit more detail than I'm going to, but let's get into it. Okay. So, your body defenses, and I didn't say immune system here because there's more to your body defenses than your immune system. So, we'll be talking about the immune system, but that's not everything. Okay. Your body has three lines of defense against pathogens. Pathogens are things that are trying to invade your body and do harm to your body. Or at least we perceive that our bodies perceive that they are trying to do harm to us. Okay, so this can be things like bacteria, it can be large chemicals, it could be fungi. There's a lot of different things that fall into the pathogen category. It's a very broad topic. All right, so you have three lines of defense. Your first line of defense is all about mechanical and chemical barriers. So trying to keep these pathogens from entering your body to begin with. So your skin, when it's intact, is a physical barrier. The mucosa, which is the tissue that lines those parts of your body that are exposed to the outside, like your lungs and your digestive system, once again, that's a physical barrier to stop things from getting in that we don't want to get into our bodies. That also includes some of our skin secretions, though. So chemicals, for instance, your tears have some little enzymes in there that destroy bacteria. Um, the Your saliva does as well. The vagina is very acidic, so that's not a good environment for bacteria to grow. Yay, we don't want them growing there. Um, your skin secretions, as far as your sweat and the oils, also have antimicrobial qualities to them. So that first line is just trying to keep these little buggies out of our bodies. But if they manage to get in, we have a second line of defense. The second line of defense consists of a few different components. Okay, so there are some cells involved in this. Some of those cells are phagocytes. We talked about phagocytosis a long, long time ago. Phagocytosis means cell eating. So these are the little cells that go around and gobble up the bad cells that have invaded our body. And we have lots of different kinds of phagocytes. These are just some general phagocytes. Anytime they run into a cell that doesn't belong there, they are going to gobble it up. We also have natural killer cells. Natural killer cells are little assassins. And what they do is they go up to a cell and they rub a hole in the wall of the cell that they encounter. And that causes water to rush into the cell and the cell lyses, it explodes. But the way these natural killer cells work is they go up to the cell, they rub the hole, and then they take off. So they're gone by the time the cell explodes. That's why I say they're little assassins. They're going to make their mark and then they're out of there. We also, in the second line of defense, have some chemicals that help with that. They mentioned in your packet the interferons, and interferons are kind of cool. Interferons are produced by virus-infected cells. So the virus has already infected this cell, and remember that viruses, when they infect cells, one of the things that they can do is they can use the cell's mechanisms to replicate themselves, and then the cell explodes, releasing more viruses to go infect other cells. Well, what these virus-infected cells do is they release these interferons, and interferons bind to healthy cells to stop the viruses from being able to infect them. So it's basically, I'm going down, I'm going to protect you so you don't go down too. So that's kind of a nice thing to do as you are dying, I guess. That didn't sound good. Anyway, another type of chemicals, and there are lots of different types of chemicals that we produce in the second line of defense. I just picked out a couple. Okay, the interferons because they're cool. Pyrogens. Pyrogens reset the body's thermostat. And so these are what cause a fever. Now, what's happening when you have a fever with the higher temperature, that's increasing your metabolism. So that's going to help with repair. But it also, remember that a lot of these substances, these pathogens, are very heat sensitive, and so that additional heat is going to harm them and not make them effective anymore. So, a little bit of a fever is actually a positive thing because it's your body's way of getting rid of bacteria. Um, but you don't want it to be too high because if it gets too high, then your own proteins can start to denature, and that's not a good thing because then they can't function properly, right? And especially since a lot of our proteins are enzymes, enzymes run all the chemical reactions in our body. We don't want to denature them. We don't want them falling apart and not able to do their jobs. All right. The third part of the second line of defense is a big one, and that's inflammation. So anytime inflammation occurs anytime cells are damaged. So it could be because something's invading your body, or it could be because you got your knife slipped and you cut your finger. So cells are damaged. So the cells that are damaged send out a chemical called histamine. And histamine causes this inflammatory response. So there are 4 signs of inflammation. There is redness, heat, swelling, and pain. The redness and heat occur because of increased blood flow to the area. It seems kind of counterproductive of increasing blood flow, especially if you cut yourself. You don't really want to increase blood flow to the area, but you do because you need that nutrients from the blood, the oxygen and nutrients from the blood to repair the damaged cells. And this is actually an example of chemotaxis, but we'll come back and talk about that later. Okay. The swelling and pain also go hand in hand. Remember, we talked about that our cardiovascular system is always leaky, and the lymphatic system picks up that leakage and returns it back to the cardiovascular system. Well, in inflammation, the capillaries become extra leaky. And so that's what causes the swelling. The lymphatic system can't work fast enough to get all that up. But actually, the swelling is a positive thing, especially if it's over a joint. What it's doing is it is immobilizing that joint so that you don't do further damage to it. But the pressure of that leaked fluid causes pain. All right, so all of these things can be happening at the same time. But the third line of defense is our actual immune system. Now, those first 2 lines of defense we say, are non-specific. They are going to respond to any pathogen or any cell damage, regardless of the source of the cell damage. The third line of defense has 3 qualities that make it unique to the first 2. First of all, it is specific. It is antigen specific. Antigens are large molecules or cells that cause this immune response. So the third line of defense, the immune system, is actually targeting specific antigens, not just any that it comes in contact with, but different cells are looking for different antigens. Excuse me. So it's very specific. We talked about the immune system being systemic. So it goes where it's needed. It's everywhere in the body. Wherever there is damaged cells or a foreign cell or a foreign antigen, the immune system is going to go there. And we'll talk a little bit about the cells here in a moment. And the last quality of the immune system that is different from the first 2 lines of defense is that it has memory. So once these cells that we're going to talk about encounter an antigen, they learn how to fight it. So the next time your body comes in contact with that antigen, they can fight it before it has any effect on your body. So this is the idea behind vaccines, is that you are exposed to antigens that are They usually say dead or attenuated, which means weakened, dead or weakened. You're exposed to those. It's not enough to make you sick. The vaccine's not enough to make you sick, but it's enough for your body to build a memory. So then if you come in contact with that again, that pathogen again, your body will fight it off before you see any effects of it. So that's kind of cool. All right, so the cells that are involved in the third line of defense in the immune system, there are two broad categories of cells. There are B cells, and the B cells are in charge of humoral immunity. Humor in this context, when we're talking about body humors, we're talking about body fluids. So this is a chemical form of immunity. This is also called antibody-mediated immunity. So the chemicals that are formed by the B cells that actually do the fighting are antibodies. And antibodies are small proteins. So they're little Y-shaped guys, and they go and they attach. There are various types of antibodies, and they work in different ways or work on some specialize, for instance, in cancer cells. Some specialize in bacterial cells. So they have different specialties. But this is a big part of our immune system, are the B cells that produce the antibodies, and the antibodies do the fighting. The other type of cell are the T cells. The T cells are in charge of cellular immunity or cell-mediated immunity. So in this case, it's the actual T cells themselves that are doing the fighting. And usually when we're talking about white blood cells being our immune system, we're talking about the T cells. That's usually what we're referring to. There are various types of T cells. There are some that are involved in allergies, specifically involved in allergies. And once again, there are some that focus on particular bacteria. Both the B cells and T cells, though, are antigen specific. They are targeting a specific antigen. Now, in both B cells and T cells, when they bind to an antigen, they start cloning themselves. And when they clone themselves, with the B cells, some of those become the B cells that produce antibodies. Some of them become memory cells. With the T cells, when they start cloning, there are a variety of different kinds of T cells they can become, but one of those types is memory cells. So once again, when we come in contact with that pathogen or antigen again, are there T cells and B cells, those memory cells, know exactly how to fight them, get fighting them, and so we don't get sick. So all of the effects that we feel when we get sick, we get, all snotty and our eyes are watery or whatever, and a throat sore, whatever kind of ailments we might have, all of that is a result of the inflammatory response, which is enhanced by the T cells. There's one group of T cells called helper T cells, and their job is to recruit B cells, recruit other T cells, enhance the inflammatory response. So all of those things that histamine does for us in the inflammatory response that make us miserable, that's actually our bodies trying to fight and win and make us all better again. So if you take antihistamines when you're feeling miserable, you'll start to feel better, but the actual illness itself might last longer because you're mitigating, you're stopping that natural response to get rid of whatever's attacking your body. So I'm not telling you not to take antihistamines. I'm just saying it might lengthen your illness a little bit. And also, if you're to the point where you can't breathe, by all means, please take antihistamines. Breathing is important. You still need to be able to breathe. But if it's just you're feeling a little yucky, maybe lay off the antihistamines if you can work your way through it, and your body will heal a little bit faster. All right. So that's all about your immune system and your different immunities, your different levels of immunity. On Monday, we'll begin talking about the reproductive system, and we'll start a whole new outline for that one. All right. Have a wonderful weekend, ladies.